Hi, my name is Nathan.
Hi, my name is Adam.
And my name is Isaac.
The project that we did is a dice game called Left, Center, Right. So the rules of the game are pretty simple. If we click the How to Play button, a tutorial will pop up in front of the screen. Basically, each player gets 3 chips. Player 1 goes first. The player whose turn it is rolls 3 dice if they have 3 chips, rolls 2 dice if they have 2 chips, rolls 1 die if they have 1 chip, and skips their turn when they have 0 chips. The player passes their chips based on what the dice show. If a player rolls a dot or a star, they pass no chips. If the player rolls an L, 1 chip is passed to the person on the left. If one player rolls a C, 1 chip is passed to the center pot. And if a player rolls an R, 1 chip is passed to the person on the right. The exit button then can be clicked to exit the tutorial and play the game.
When it is a player's turn, the roll dice button appears, along with a text indicating that it is the player's turn. Both of these will disappear after rolling. Right now, the opponent's rolls are automated. And in the middle, there's a table that keeps tracks of all the players' rolls. So for our first core component, we have random number dice generation. So the program first counts how many chips player 1, player 2, player 3, and the center all have. It then uses this to determine how many dice player 1 should be rolling based off of how many chips that player has. It generates a random number and decides if that number falls in the categories side 1, side 2, side 3, side 4, side 5, or side 6. And then it uses that for the animation process and to update chips. This works for all 3 dice for all 3 players. So for our second core component is total chip counting. In each subsection of dice where it decides if the face is 4, 5, or 6, 1 chip is subtracted from the player and it is redistributed to other players. If for player 1, if a 4 is rolled, 1 chip is subtracted from their count, and player 2 gets an additional chip in their count. If a 5 is rolled, the player gets a chip subtracted from their count, and the center pot gets a chip added to their count, so on and so forth.
One reach component is the dice animation. How the dice animation works, which is shown over there with the code, is a pattern of dice sides, which are shown switching rapidly, but slowing down slightly. And then by the time that the dice animation ends, the true value of the die, which is determined by a random number generator, is shown. The dice animation is only played when you roll the dice, but not when other players roll the dice.
For our second reach component are sound effects. When the button is pushed or a player turn is ongoing, a sound is played using audio read, saving files, and playing the sound. Each dice is rolled separately and has their own column. In the dice numcheck, it takes T1, which is the result of the random number generation, and assigns it to the value of the dice roll. Rows in the table are added using array concatenation, utilizing the semicolon and keeping the current data. Additionally, the table will also display which player rolled those values. So ThingSpeak never ended up working, but we do have a demonstration of how we would have used it through this rudimentary alternate program that we made that utilizes ThingSpeak. This was made following the remote gameplay tutorial, and it has the channel properties of ThingSpeak. It decides what the player's number is. It has the players wait for each other, and it has them send their data to each other and update their scores. One challenge we had was during the implementation of the opponents. Since we couldn't use ThingSpeak, we created 2 functions in order to simulate the rolling. This meant not only did we have to update each player's chip count, the table also had to reflect each roll and change. That also involved writing code multiple times to adjust for the amount of dice that each player had.